Good morning, good morning. Welcome back. Well, what I want to do is continue with GCSE mathematics, simple compound interest, okay? Or simple interest and compound interest, okay? Now, again, you need to write out the work and the exercises for yourself in order to enable your own style of learning to come through. Okay, it is important that I'm only showing you my method and my style of learning. It's important that you find your own style of learning and what works for you. It is important. Now, always use pen and paper. Old-fashioned, yes, I know, but it works every time. It works. It is what helped to produce some of the world's greatest engineers and scientists. Okay? Right. Mathematics, simple interest and compound interest. Okay? Now I want these easy to be seen, so let me see if I can make it bigger enough and without losing the get that into view. Okay, without losing it out of view. Okay. Here we have simple interest. If you borrow money from a bank or building society, you will be charged interest on the amount of money which you borrow. The sum of money which you borrow is called the principal, P. The principal, P. Okay? And let me just get my pen so we can highlight these and point them out. Okay? Every time. Okay? It's called the principal. Okay? P. The time T over which you borrow the money is given in years. Time T, okay? And that is our T here, okay? Is given in years. Example, 2 years, 6 months must be converted to 2.5 years or 2.5 years. The rate R, okay? Now that's the rate of interest. At which you borrow the money is given as a percentage. Example, 5% means that £5 will have to be repaid on every £100 which you borrow. Okay? Now the simple interest which you pay, SI, can be calculated by using the following formula. SI, simple interest, equals P, and we said what P was, principal. R, we said what R was, the rate, and we said T was the time, okay? And all that is over 100. So we rewrite this as this now, okay? So that is now that, okay? SI equals P times R times T over 100. Now another quality which is sometimes given is called the amount. Amount equals principal plus simple interest. Okay? Let's go back, make sure to show that it is in view. Okay. Now never mind this, you can see how I left it outside in the shed and it got damp and so forth. Never mind that, that's just irrelevant. That's just the old age of the paper, okay? but the principle and the material of the work is still relevant to this day. Mathematics cannot get old, it does not die away or age. It goes on for an eternity. Okay. Now, reading through the following examples, find the simple interest on £300 at 2% for 5 years. So let us look at how this works. Extract the information, £300, percentage rate is 2%, time is 5 years, substitute these values in the formula. So remember your formula, put that into place. Now you need to multiply this for yourself so you can see that the stages that's been implemented, and you need to do this so that you understand and find your own method of learning and style of learning as well. Okay, so but what I'm going to do here for you, I'm going to just take this here and I don't really blot out any mistakes I make, so I'm just going to do this as an experimental view, okay, for yourselves to consider. So that's times that, okay, times 2 equals 600. Equals 600. Now we then have, taking this, we then have 600 over times 5 over 100 equals Now, I'm doing this the long-winded way because some individuals, even though some of you are smart, some others may not understand the principle behind it. So it is important that, sorry, I'm just trying to get my teeth in. It's important that we show how it is done so they can develop their own style of learning and application, okay? Now that then equals 600 times 5 equals 3,000, okay? Over 100. Equals equals 30. That cancels out, that cancels out, that cancels out, and that cancels out, and leaves you with 30. Okay? And that answer we know now is correct. Okay, that's correct. Now I take time initially to show you how it's done, okay? Because I don't want for you to feel lost, okay? Let me just pan back a bit. Just fine. We can get it all into view, okay? And here we have similar thing, okay? Same principle applies, okay? Okay. Now again, here, find the simple interest on at 2% for 9 months, okay? Now here, slightly different. Time equals 3/4 of the year. 9 months equals 3/4, so that's equal 0.75. So here you need to look at simple interest, putting in the formula, okay? You have 300, 2% times 0.75. It's not times 9 months, not 0.75 of the year, okay? And you find that will be it come down to £4.50. Now again, write it out, do the calculation for yourself, make sure that it works and it tallies, okay? Here we are, have another large figure. If £600 is invested at 7% per annum, how long will it take for the amount to reach £684? Okay, so you have your information, put rate, simple interest, time, we don't know. So so we need to, what do we need to do? Taking our formula, let me just come back, taking our formula, hang on, let me just go back a little bit to, oh come on, do I have to go back to file? What do we need to do in this case? We need to rearrange our formula for t, don't we? Okay, and as I said here, we were 0.75 over 100, go give it 4.50. The SI formula can be rearranged so that t becomes 100 times simple interest over p times r. Okay, and we could change the formulas around in each case. So here we're transposing for t, ignore my line. Here we're transposing for r, okay, and here we're transposing for p. All this showing you is how to do the transposition. Now you should be familiar with transpositions already, okay, because it's something that you would have had to do previously to make sure you understand the concept behind it, okay. And back to where we were. If £600 is invested at 7% per annum, how long will it take to reach 684? Okay, we don't have a time, so we need to transpose for t, okay. And again, I like to write out the formulas for myself from the beginning, so again, please remember the formulas, how it works. So here you are now transposing for t. We have 100 times s simple interest. We know the simple interest is 84, okay, times p times r. Okay, so again here multiply this out. Do the top first, okay? Do the top first, then the bottom, okay? Okay. And the time will give equal to 2 years because you're looking for t, okay? The time. Now do the calculation for yourself. Make sure you find that that it arrives at that solution correctly. I'm not going to do this for you now because I've done the initial stages at the top in the first stage at the beginning. So this is now for you to work out for yourselves, okay? And again here, find the percentage rate at which 441 will gain £77 simple interest in 6 months, okay? And again here you're looking for the rate at which it will grow. And here we're looking at R. And remember we said we were looking how we transpose for each one in turn, okay? And that's our formula here, okay? Similar thing in here as well, okay? So I'm not going to don't need to do anything on these for you. Now these are for you to do yourself. Write them out, do the calculations, use the formulation, put it into place. Get and find your own style of learning. And that is paramount for yourself to comprehend and understand. And when you do this on the screen for yourself and write it out for yourself, you can do it in the classroom without any difficulties. Get it done, okay? Compound interest. Now compound interest, this is different from the earlier section on simple interest in that after the first year the interest is added to the principal, thereby giving a new principal for the second year. Interest is then calculated on this new principal to give the interest after 2 years and so on, i.e. you are getting interest on the interest. This type of interest is used by building societies. For the GCSE you cannot put the figure given to you in a formula as in simple interest. Instead, you have to work through the problem as shown below. So let's have a look at that. The setting down of these problems is very important. Example 1. Find the compound interest on £4,000 invested for 2 years at 5%. The principal, first year, £4,000. Interest, first year, £200. Add these together, give principal second year, okay? Now here you have principal second year, £4,200. So again, you're now adding that has now gained £10 additional plus, so you're putting interest on the interest, okay? Principal third year and so forth, okay? And look at how this has now grown. That's £4,410. And here you have and here's your interest. Now here we're just showing you an alternative method, okay? But the alternative method is totally your choice if you wish to use it, okay? So bear that in mind. Sorry, excuse me, pardon me. A little wind just tried to escape from my voice box. But I did try to trap it, but it didn't quite work. And here you have the principle of this again, okay? So you can see that we're doing a lot of this, but doing this work makes you get practice, practice, practice makes perfect, okay? And here we are, look at that, okay, for yourself. Okay. And let's use that ourselves, okay? Again, this is for you to do. I'm not going to try and do this all for you. Okay, you need to be able to do some of this for yourselves and be familiar with the work and style. Okay, here are your answers. Okay, you don't need to look far, but try and do them for yourself before you look at the answers to confirm that the answers are correct. Okay, thank you. I hope you found this useful. Let me just go back up now slowly so that I can make sure that it's all in frame. Okay, I don't want a situation where it's not in frame. Okay. Okay, we're coming to our final pages now. Okay, and thank you. Well, I hope you found this useful. Have a good day. Bye bye for now. Thank you.